steel structure is a framework composed primarily of steel components, such as beams, columns, trusses, and plates, that are connected to support loads and resist forces. Steel is widely used in construction because of its high strength-to-weight ratio, ductility, prefabrication ease, and recyclability. Steel structures play a vital role in modern civil and industrial engineering due to their high strength-to-weight ratio, ductility, durability, and ease of fabrication. They are widely used in the construction of buildings, bridges, towers, industrial plants, and other infrastructure requiring both strength and flexibility. To ensure safety, efficiency, and cost-effectiveness, engineers rely heavily on structural analysis and simulation tools to understand and predict the behavior of steel structures under various loading conditions. Common applications include buildings, industrial halls, skyscrapers, bridges, towers, and transmission lines, offshore structures, industrial plants, beam, column, composite column, welded steel angle, steel concrete composite beam. Steel structure analysis involves determining the internal forces, moments, stresses, and deformations that occur in structural members, such as beams, columns, and trusses, when subjected to external loads like dead loads, live loads, wind, or seismic forces. Traditional analysis methods, such as the stiffness method, matrix analysis, and plastic analysis, form the theoretical foundation for modern computational techniques. Steel structures are analyzed to ensure safety, stability, and serviceability under applied loads. Dead loads, live loads, wind loads, earthquake loads, temperature effects. With advancements in computational technology, numerical simulation, particularly using the finite element method, FEM, has become an essential part of structural engineering. Simulation tools like ABAQS enable engineers to model complex geometries, material nonlinearity, and dynamic effects with high precision. Through these simulations, engineers can visualize structural responses, identify potential failure points, and optimize designs before actual construction. In addition to static and dynamic load analysis, simulation techniques are increasingly used to assess buckling behavior, fatigue life, fire resistance, and progressive collapse scenarios in steel structures. Moreover, the integration of building information modeling, BIM, and parametric design has enhanced the efficiency and accuracy of design workflows. Overall, steel structure analysis and simulation is a crucial discipline that bridges theoretical mechanics and practical engineering design. It empowers engineers to develop safer, more efficient, and more sustainable steel structures through the use of advanced computational modeling and performance-based design principles. This package offers a complete course on steel structure simulation using a box software. The tutorials include 21 detailed and independent projects, each supported by research-based models. Every project provides step-by-step instructions through English language videos, CAE IMP files, and supplementary research papers. The course covers various steel material include elastic, plastic, ductile, and shear damage, Johnson-Cook hardening, and damage. These are applied to a wide range of structures, including beam column joint, bolt, steel angle, gusset. Analyses include seismic and cyclic loading, bending, compression, tension, flexure, bolt failure, fracture, shear connectors, and FRP reinforcement. The course includes 21 practical and comprehensive tutorials that you can find each model in the description page. FEM provides a powerful and flexible framework for realistically analyzing and simulating concrete structures. By capturing material nonlinearity, cracking behavior, and complex geometries, engineers can predict performance, optimize design, and ensure safety and reliability. This package is ideal for civil and structural engineering students and researchers. With lifetime access to downloadable resources, you can learn at your own pace anytime and anywhere. I hope you have a good understanding of this package, but for more questions and details on each section, please visit our website Engineering Downloads or email us at info@engineeringdownloads.com.